Picture this: you're an intrepid explorer in the year 2345, journeying to the distant past to witness firsthand the greatest extinction event in Earth's history, the end of the dinosaurs. You might imagine colossal asteroid hurtling towards the planet, crashing into shallow seas, and sending up a huge dust cloud that blocks out the sun for months or maybe years. This vision is so ingrained in popular culture that it's easy to forget. There were probably no shortage of terrified onlookers at the time wondering the same thing. What the hell just happened? And given enough time, these observers would have been right to make that assumption. But if you want to see another kind of extinction event, perhaps one that even more closely matches our own extinction event, you'd be better off stepping into the Cretaceous period around 76 million years ago, where you could watch a supercontinent break apart. In fact, this process was already underway when the asteroids hit. While the first asteroids began falling around 75 million years ago, marking the beginning of the lacustrine period, the real carnage didn't start until 20 million years later with the separation of the supercontinent of Pangaea. By then, the asteroid bombardment had already stopped, but life on Earth would soon find itself in dire straits once again. It's called the Cretaceous annihilation event, and its impact was much more drawn out than the relatively quick impact winter caused by the asteroid. In fact, the Cretaceous annihilation may have caused the mass extinction we associate with the dinosaurs because it was actually more deadly. But despite its importance, this event is not commonly taught in schools, and is almost never mentioned in movies about asteroids. Why is that? Well, although this extinction event is well documented in the fossil record, scientists can only speculate about what really happened since they don't have any direct evidence. We do know that the Cretaceous annihilation event saw the extinction of around 75% of all marine species and 75% of terrestrial species. However, according to a study published in November 2023 in the journal NUS, the asteroid impacts weren't responsible for this mass extinction. Instead, it was the slow-motion apocalypse wrought by the breakup of Pangaea. The reason for this, other than the usual tectonic plate movement, is still up for debate. Some researchers believe that the intense volcanic activity that accompanied the separation of the supercontinent created massive climate shifts that led to the mass extinction. Others argue that the disruption of ocean currents by the new land masses starved the deep sea of oxygen, which triggered the extinction event. But one thing is for sure: the death of the dinosaurs wasn't as sudden as the asteroids would have made you think. So when did life on Earth actually go extinct? Well, the answer depends on how long you think the dinosaurs were around for. Given that many depictions of the dinosaurs show them living side by side with early humans, it makes sense that you might assume they went extinct at roughly the same time humans evolved, 300,000 years ago. But the truth is that humans and dinosaurs had plenty of time to make friends. The dinosaurs lived from around 230 million years ago to 66 million years ago, meaning they were around for 164 million years. That's longer than the entire Mesozoic era, that came after the Paleozoic and before the Cenozoic, which includes the current Holocene epoch. And during that time, the dinosaurs went through their own rise and fall, which started much earlier than the asteroids would suggest. The Triassic-Jurassic extinction event, which took place about 200 million years ago, wiped out around 80% of all species on Earth. It's generally accepted that this extinction paved the way for the dinosaurs to become the dominant terrestrial vertebrates. But some scientists now believe that the rise of the dinosaurs was actually more complicated than that. In a paper published March 29, 2023 in the journal Science Advances, one team argued that the rise of the dinosaurs was actually delayed and caused by the latest mass extinction event. According to lead author and paleontologist Dr. Eric Rignett, previous research has largely overlooked the possibility that ecological vacancy played a role in the origin of the dinosaurs. Vacancy, in this case, means that the ecosystem suffered a net loss of species diversity, allowing the dinosaurs to take over. Dr. Rayner looked at the age of first appearance of major groups of animals in the fossil record across 3 different regions in what is now North America. He found that while most of the major dinosaur groups appeared relatively early in the fossil record, their remains are conspicuously absent from strata younger than the mass extinction event. For example, the oldest fossils of ornithischians and theropods come from strata less than 1 million years old, yet they disappear from the fossil record until the mass extinction event is over. The authors say this suggests that the major dinosaur groups actually first appeared before the mass extinction, but their bones were simply lost to erosion. The fact that they disappeared from the fossil record right at the onset of the mass extinction also indicates that the event significantly impacted their diversification. However, it also shows that this extinction paved the way for the dinosaurs to flourish. So while the mass extinction didn't directly kill off the dinosaurs, it did set the stage for their future success. But before they could become the kings and queens of the Cretaceous period, the Earth had to endure yet another mass extinction event, this time caused by asteroids. In fact, the asteroid bombardment that marked the beginning of the lacustrine period was the first of several such events to occur over the next 20 million years. So it makes sense that we often conflate the lacustrine extinction event with the end of the dinosaurs, given that this bombardment peaked around 74 million years ago. However, the peak of the asteroid impact is relatively recent compared to the first asteroid that struck Earth during the Cretaceous. The earliest evidence of these impacts comes from around 75.5 million years ago from both continental crust and marine sediments in what is now Haiti. In fact, researchers analyzing these layers found microdiamonds known as nanodiamonds, which form only under extreme heat and pressure, like those found in impact craters. In a study published December 2022 in the journal AGU Advances, geologist Dr. Gareth Collins and his colleagues used a computer model to calculate the energy released by the asteroid bombardment. Their model showed that the asteroid impacts had an energy yield equivalent to around 10 trillion tons of TNT, which is about 4 million times the energy released by the Chelyabinsk meteor. To put this in perspective, it's roughly 10,000 times more energy than the asteroid that killed the dinosaurs. However, unlike the impact that killed the dinosaurs, which occurred over a relatively short period, the late Cretaceous asteroid bombardment was spread out over 500,000 years. In fact, analysis of the sediment layers in Haiti revealed that the bombardment was actually two distinct events, one around 75.5 million years ago, and the other between 74.5 and 74.3 million years ago. The latter is notably closer to the end of the Cretaceous and the end of the lacustrine period. These asteroid strikes also seem to correlate with two previously unidentified impact craters in Saudi Arabia and Brazil. However, the energy released by these impacts isn't enough to explain the Chicxulub crater found in Mexico, which dates back to around 66 million years ago. That's why Dr. Collins believes there must have been other smaller impacts that haven't been identified yet. Ultimately, the researchers concluded that the energy released by the asteroid bombardment was great enough to have driven significant environmental and climatic change. And yet, they found that it had little overall impact on biodiversity. Even though the asteroid impacts played a major role in the environmental changes of the lacustrine period, scientists agree that they were not solely responsible for the mass extinction event that ended the age of dinosaurs. Instead, the most likely cause is the Cretaceous annihilation event, which began around 76 million years ago with the separation of Pangaea. So which event should get more attention? Well, given that the asteroids were responsible for killing the dinosaurs, which I admit are cooler than mammals, you might think that the asteroid gets top billing, but it was the Cretaceous annihilation that arguably caused more extinctions. Plus, if it weren't for the asteroid, we wouldn't have any iconic images of horned dinosaurs, feathered predators, or sauropods taking off from the ground. So maybe learning about both events is the best revenge. If you enjoyed this video, please subscribe. And if you have a question about the universe that you'd like us to answer, leave it in the comment section below and it might be selected for a future episode.